In this video we are going to see how to draw box and whisker plot. This is one of the statistical graphs. The data in this rectangle is the given in the question, and what we have to do, we have to find the quartiles and interquartile range for these numbers, and then with the help of that we will draw box and whisker plot. The first step is we have to arrange this data in either order. We have arranged this data in ascending order and count the number of values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are 12 values. That is 12 observations. First we have to find the median of this data. The median of the data, as there are 12 observations, these are even observations, so there will be two central values. These will be the central values. To find the median, we have to average these two values, that is add these two and then divide the answer by 2. 8 plus 8, 16, and divided by 2, it is 8. So therefore the median is 8. This is our median. And you know that median lies exactly in the center of the data. So median will be over here in this position where this arrow is showing the position of the median. The next we will divide the data from this position into two equal parts. Now just count the observation in this first part of the data, first half part of the data. 1, 2, 3, 4, 5, 6. Now find the median of this first half of the data. So there will be again two central values, that is 5 and 6. Take the average of these two. 5 plus 6 is 11, and 11 divided by 2, it is 5.5. So the median of this first half of the data will be 5.5. This is called first quartile or lower quartile. In a similar way, we will find the median of the second part of the data, that is second half of the data. And again these are 1, 2, 3, 4, 5, 6 values. Again there will be two central values, that is 9 and 11. 9 and 11. So 9 plus 11 is 20, and 20 divided by 2 is 10. This 10 is the upper quartile of the whole of the data, and it is also called Q3. And the difference between this upper quartile and the lower quartile is called interquartile range, which is 10 minus 5.5 is equal to 4.5. Interquartile range is 4.5. In this data, this 3 is the minimum value and 20 is the maximum value. Here the minimum value is 3. Now we are going to draw the box and whisker plot. So let's start. Take this first line 0, 1, 2, 3. Draw a small line here. This is the mark of the minimum value. The first quartile is 5.5. It's 4, 5, and 5.5 will be over here. This is the Q1, first quartile. Q3 is 10. 5, 6, 7, 8, 9, 10. 10 will be over here. This is Q3 line. Now join these Q1 and Q3 lines. This will give us the box of the plot. Now this is the box of the plot. Now mark the maximum value position. Maximum value is 20, and this is our maximum value mark 20. Add the 20th step from here to here. Now join this minimum value with the midpoint of this box and this maximum value with the midpoint of this side of the box. Note point or put the median line. Median is 8. This is our median line. So this is our box and whisker plot. And look, this 20, this is very large value if you compare the rest of the values of the data. So because of this large value, the whisker on the right side of the box plot was longer than the whisker of the left hand side. See, this whisker is bigger than the whisker on the left hand side, and this box shows the 50% of the data. This shows that the range of the data is very large, but the spread of the in the central 50% value is not so big one. The spread of the central 50% is small, but the range of the data as a whole is very large. Central 50% values are very close to each other, but the range of the data looks very large. So it means that interquartile range is a better information as compared to the range of the data. This is question number 2. Illustrate the following set of test scores using a box and whisker plot. Here we have values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 observations. Whereas in the last one there were 12 observations. So these are the odd number of observations. In the previous example there were even number of observations. Let's see how to draw the box and whisker plot in this case. The first step is to arrange the data. So this data is arranged over here. The next step is to find the median. There are odd number of values, so median is exactly in the center of there is only one value of median, and that is 17. So 17 is the median right now. Now divide the data into two 50% portions. Divide this data from this median position into two equal parts. So this is our first half of the data and this is our second half of the data. Now find the median of this first half of the data, and that is 9. So this 9 is our first quartile, and the median of this portion is 20, and this 20 is our upper quartile. Now we have noted down the median, lower quartile, upper quartile, and 5 is the minimum value and 22 is the maximum value. So we can find easily interquartile range. Now we are going to draw the box plot. The minimum value is 5, so this is the location of 5, and the first quartile is 9, so this is the first line, first side of the box at 9, and the upper quartile is 20, and this is the second side of the box at 20. So I will join these first quartile and the third quartile, and this will give us the box of the plot. And the maximum value is 22, so mark at 22. Now join this maximum value with the midpoint of this side of the box, and join this minimum value with the midpoint of the left side of the box. So this, and then median is 17. At 17 draw the median position. So this is our whole box and whisker plot, and in short we called it box plot.